So in this video, we are going to discuss a problem based on maximum power transfer theorem. So the question is, a loudspeaker is connected across a terminal called AB. Okay, so this is my AB. So in this one, a loudspeaker is connected. It has some internal resistance. Okay, so what should be the value of the impedance of the speaker? So what will be the impedance of the speaker? In order to obtain maximum power. Okay. So they have given, before that they have connected inductance and its values J4 and resistance values 3 ohm, and they have given source and voltage source, that is AC source, and its values 10 angle 30. And you have a parallel impedance connected across parallel to this loudspeaker. Okay. So the question is to obtain the maximum power. So if I want to obtain the maximum power, I need to apply the maximum power transfer theorem. So if maximum power transfer theorem is to be applied, then we need to go for the Thevenin's equivalent circuit for this one. Okay, so first what is the step? I have to remove this loudspeaker, and they need to find the RTH. Okay, so if I want to find the RTH, the voltage source must be 0. So I have to short circuit this one, and its values 3 J4 and minus J5. Okay, so this is my RTH value. So in order to find the RTH value, so RTH is equal to, this is in series, so you will get 3 plus J4. 3 plus J4 is in parallel with minus J5. Okay, so I can write 3 plus J4 into minus J5 divided by 3 plus 4J minus 5J. Okay, so this is nothing but minus J15 plus 20 divided by 3 plus J, 3 minus J. Okay, so I have already told you how to calculate this complex function, right? So you write 20 minus 59, so the value is 25, angle value is minus 36. 6.86. Okay, and 3 minus J, I can write it as 3.16 angle minus 18.43. So 25 divided by 3.16 is 7.91 minus 36.86 plus 18.43 is minus 18.43. So this is a polar form, right?
But it's already nice.
Of cherry. Boy, that word. So the next step is to find. So if I want to convert this, okay. So you can convert this polar form into again a rectangle form. Okay, that is in terms of complex number form. Okay. So next to find VTH. Okay. So this is my circuit.
Maybe it's matter.
So here you need to find the value of VTH. So what is VTH now? VTH is equal to total voltage into minus J5 divided by 3 plus 4J minus 5J. So this is nothing but 1030 minus 5J divided by 3 minus J. Okay. So how to write minus 5i? Minus 5i, I can write it as 5 and minus 90, right? And 3 minus I can write it as 3.16 angle minus 18.43. That is 50 minus 60 plus 18.43 divided by 3.16.
Fine, indeed. Do it like that, but then. Okay, that's a very needed. Good. What are you trying to do?
So answer is 41.57. So now I am going to substitute this one in this is my VTH, right? The VTH value is the value 15.86 angle minus 41.57. That is standard to RTH, right? And that value is 7.911. Minus 18.43. Okay, and the loudspeaker value. Okay, So I need to convert this 7 point this polar form to a rectangle form. Okay, so if I convert this one, I will get this one is equal to 7.5 minus j 2.5. Okay. So if this is the value, this impedance must be, okay, this impedance must be 7.5 plus j 2.5. Okay. This minus should be converted to plus. Okay. So if this is the case, you will get the maximum power. So the maximum power, P max value is P max is equal to VTH square divided by 4 RTH. Okay. So VTH value is 15.86. Okay, 15.86 square divided by 4 into RTH value. This is RTH value, that is 7.5. So if I substitute, I will get the answer as 8.32 watts. So at the later part of the video, I will explain how to convert this 7.9111 angle minus 18.43 into this form. Okay. So I hope this video is useful for you. Bye.